Welcome back to the deep dive. Today, our mission is to really pull back the curtain on the architecture of organized power. Specifically, how system integrators handle the just huge complexity of powering dozens of 12-volt devices without, drowning in a sea of wall warts.
Right.
So we're going to be diving into the PureLink RPS-1218. It's an 18-channel DC rack power supply.
And this thing is really the organized shortcut to central power management.
Yeah.
It's the tool that takes that sprawling, unreliable mess of individual power bricks.
The wall wart chaos.
Exactly. The wall-wart chaos that just plagues large AV installs, and it consolidates everything. Power for up to 18 devices into one single clean component.
And it's just one rack unit or one U component. I mean, for space optimization, that is absolutely key.
Yeah.
And it's built for resilience. I see it uses lateral cooling, which that's not just a minor detail, is
Yeah,
it?
not at all.
Yeah.
It's actually vital for the system's longevity.
Yeah.
When you're consolidating this much power in one place, managing heat is, well, it's fundamental to getting reliable performance.
Okay, so that brings us to the core of the design, I think.
It does. While the RPS-1218 delivers a pretty robust total maximum current output of 20 amps, the power it's not distributed uniformly. And understanding that strategy is essential for you.
Okay, so let's break this strategic split down. You've got 16 channels, right? Channels 1 through 16. And those are rated at 1.6 amps max each. But then you have these two workhorses, channels 17 and 18.
Yeah, the high draw ports.
They jump way up to 5 amps maximum each. So I have to ask, why force an architect to be so precise about where they plug things in?
It's because professional AV components, they just vary wildly in their power needs. The low amp ports are perfect for, simple signal extenders or small converters.
Sure.
But those high-capacity 5-amp ports, they are absolutely essential for high-power devices. Think powered fiber optic transmitters or some of the more demanding HD-based units.
Right, things with much higher peak current requirements.
Exactly. So mapping the power draw of every single component, that instantly dictates your hardware layout. It just optimizes for efficiency right from the start.
And what about safety? I mean, we're talking about a lot of power here. It uses individual automatic PTC fuses on all 18 channels. Is that level of complexity overkill?
Not at all. It's
Yeah.
pure risk mitigation.
Right.
And that translates directly into savings on downtime.
How so?
Well, the automatic PTC fuse is self-resetting. So if one connected device temporarily shorts out, the fuse trips to protect the circuit, and then it automatically restores power once the fault is cleared.
Oh, okay.
That self-healing capability means zero maintenance calls just to replace a standard blown fuse. It dramatically increases system uptime. Plus, it's UL listed, which gives you that critical third-party safety assurance.
Beyond protection, the unit provides, from what I can see, excellent real-time feedback. You don't have to guess what's going on inside. You get a front panel, digital system, volt, and amp meter. And then every single power output has its own dedicated diagnostic LED indicator.
And that granular LED feedback is priceless for quick troubleshooting. If one of your extenders is overloading its circuit, you know the exact port instantly.
No guesswork.
None. And the connection itself uses professional Phoenix output terminations. They're high reliability and ensure a really secure connection, which simplifies wiring, especially when you're managing 18 lines.
In terms of setup, it's also globally flexible. It accepts switch selectable input from 110 to 220 VAC. Total consumption is about 400 watts under max load.
And this unit is very much an ecosystem component. I mean, while you could use it generally, it's really engineered to work seamlessly with PureLink's own product lines.
Like their Media Access, Pure Media, and HD Tools products.
Precisely. And that native compatibility often means, standardized pinouts and monitoring protocols are already supported. It just drastically simplifies and speeds up the whole installation.
Right. And for logistics, it's a standard 19-inch rack piece, weighs around 4 kilograms. Today's price looks to be about $629.99, and it's backed by a 3-year limited warranty. So let's synthesize this. What does this all mean? The RPS-1218 basically takes chaos and transforms it into a highly resilient, centrally managed power delivery matrix.
It really does. It gives you high-density power, that granular self-resetting protection, and real-time visibility. It optimizes both install time and long-term system health.
It effectively removes that weakest link in the chain, the decentralized, unreliable wall supply.
And it gives the system architect absolute control and, just as important, confidence in the entire power infrastructure.
Exactly. Which brings us to our final thought. Considering the RPS-1218 splits its capacity so precisely with those two specific high-amp ports versus the 16 lower-amp ones, how does knowing the power draw of every single component dictate the fundamental layout and ultimately the total lifetime cost of ownership for an entire professional AV rack? The power map, it really is the blueprint for system efficiency.